Hello folks, welcome back. This is Mr. Singh. In this video, I'm discussing general understanding of programming languages, purpose of programming languages, how they have changed over the years, and why we will be going over Java in this course. So let's start with the purpose of programming languages. Why do we need any programming language? What purpose does a programming language serve? Um, to discuss that, I need to go over what is the purpose of a computer? What purpose does computer solve here? Computer can do computations or repetitive tasks that are at times boring really well. You see, if you want to multiply two numbers, every time there could be 5-digit numbers, 20-digit numbers. Computer can do that really well. So these big computations, computer can do something you want to do again and again. You don't want your dad to wake you up at 5 o'clock in the morning every day. You can just program that on your phone when you set up an alarm. So these are the things computer is really good at. Now, in order for computer to do these things, you need to communicate with computer. And the language that computer speaks is called binary. Now, binary is made up of zeros and ones. That's kind of the power symbol comes from there too. So the language computer speaks is binary, that is based of zeros and ones, and then these zeros and one, that sequence also changes based upon the processor you have, right? Based upon the processor that your computer has. So based upon the processor your computer has. So now, in order for you to communicate with the computer, either you know binary or you need to know about a translator. Now, if a language has only two digits like binary, then writing or talking to that computer will be very cumbersome because every little thing, for example, just to write letter number 10, you would do something like that. That would be 10 in binary. So there'll be too many digits and it will be decently complicated to communicate to a computer if you had to speak binary. So what do? Is you find a medium. Hey, can I do in something English-like manner? Can I write something in English? That can be converted into this binary code that computer understands and does the work. And that is the goal of a programming language, to come up with something that is English like, not exactly English, because English can be interpreted in more than one ways. You need something that is concrete, that is yes and no, that's black and white. So you need this is the role what programming languages serve. They serve a role of a medium where you can write. So now each programming language has a certain set of rules it comes with. Each language has certain rules. As long as you follow those rules to the core, they have a translator. That translator each language has, that's called a compiler. Now that compiler is basically your translator. That converts whatever you've written in English-like language into binary or machine language. That can be read by the computer. So that's the role. That's the purpose and role of programming languages. And when we see the evolution of programming languages, if I go to my first generation or low level languages, right, my low level or first generation of, well, first generation is just a machine language. Then comes your assembly. And then comes your high level languages, right? That's the third generation. This is your high level languages. These are your C, C++, Java, C#, and so forth, right? So what is changing over the years? Assembly would be the second generation, and high level would be your third generation. By the way, we are now in fifth generation of programming languages, where fourth generation of programming languages would be languages they solve a specific task like SQL that just gets information from the database, or something like a R that just does the mathematical part of the things. And your fifth generation of languages, they're more of problem solving languages. You explain the problem to the computer, you write the problem there, and computer comes up with the algorithm using AI, and that's the fifth level. And that's all I'm going to go into this thing. So far so good. We understand the purpose of languages. We get the different generations of languages. And why do we have different generations of languages? If you look at machine language, then you're talking complete binary. After that, when you go to assembly is a level above machine language, that still gets compiled or converted into binary, and then you come into high level languages. Now, high level languages, if I need to talk more on that here, assembly C. So we started with the languages that were more functional. By functional, and then we are at procedural languages, and then we come into our object oriented languages. So this is the way in which you solve a problem. Meaning, let's say you're solving a problem of gradebook. We all know Genesis. We're making a Genesis, and how do I go about making Genesis? Is I say, hey, I need to find the average. I said, I'm not going to find this all the time. I'll write a function called average that takes two numbers and finds the average. Well, then I need average. What if I have three number inputs, right? Instead of two, I make another average. Well, I need to find GPA. So we got another function to find GPA. Well, I need to enter grades. So we keep on adding more and more functions in the program, and let's say we run the show from here, and we just keep calling different functions. Now, that's one way to look at Genesis. Another way to look at Genesis is we say, hey, what are the entities or nouns that we need? And again, I'm discussing Genesis. When we say nouns, we need a student in there. Okay, so this is gonna be my student. Well, we need an administrator in there. We have an admin. We need a teacher in there. We have a teacher. We need a parent in there. We have a parent. So these are different entities or classes. They make these different objects that are gonna interact. Student will have grades. Teacher will have these students. Teacher can access that many students and run some reports on them. Admin will have certain teachers in there, and students will make part. Parent can see the reports. Well, report will be an entity too. And everything about the student's name, grade, age, class there, and all that will be part of student. So by separating things into different entities that interact with each other, that was the premises of object-oriented programming. So that's kind of clear to. So now by looking at things as objects, um, again, we started with more functional programming languages. Over the years, we said, can we look at them as different objects interacting with each other? Two different approaches of solving a problem. More prevalent is your object oriented way, object oriented programming. Oops. So that's more prevalent now. That way simplifies thinking. All right. So purpose of programming languages is to interact with the computer. Over the years, we had different levels of languages. Um, and then we understand our functional and object oriented languages to some extent. I'm not trying to go into any details here, but want to give you a preview of why we are doing what we are doing. So, good so far. Next thing I want to talk is how languages have changed a little more. So starting with assembly, where you're writing everything in binary, then you go to assembly, then we go to C. Writing C has pointers and all those things. Right, and C is functional. It's not object oriented, right? It's just procedures there. Procedural rather. C is procedures there. Then we come to C++. C++ has pointers and is object oriented. It's an object oriented programming. So C++ gave us this, but C++ was still quite difficult to write. Now C++ is tied to the machine. Remember, I said each machine has its individual binary that could differ from machine to machine. So that machine language, so C++, if something is written in C++, and is compiled for iPhone, that will work on iPhone only. That will not work on, it will need a different compiler from C++ to Android, C++ to Windows, C++ to Mac. So in this paradigm comes in Java, and with Java, so the C++, these languages are compiled. Compiled means they need their own compiler. So each language has their own translator that converts it into machine language. Java came up with, instead of compiler, it came up with just-in-time compilation. So now this is interesting, because what Java did was Java said we will produce using a compiler. Using a compiler, we will produce bytecode. Now, bytecode is not directly the machine language. Bytecode is what would work on Java's virtual machine. So, machine also, Java wrote a code for the machine, made it a virtual machine, JVM, and this bytecode runs on JVM, that runs on top of the processor. So now, what advantage does this give Java? Java becomes write once, and run anywhere. Java is on the maximum number of machines in the world today. It is on your refrigerators. Java is on houses, kitchens, robots. Everywhere is Java, because once you wrote the code in there, you have bytecode that could be run on JVM. You don't need to be tied to the machine. So that's why Java is everywhere. Still, one of the top three languages is Java at this point. Java, Python, and JavaScript are all tied. Now, if I talk a bit about Python, how does that work? Now, Python is interpreted. So interpreted, there are three levels. There is a compiled, there is just-in-time compilation, and Python. Python is interpreted. Meaning as the code is so code is written in Python, it is stored in a file, right? So every time you want to execute, so it's a real code written. So you give that file. As the compiler reads through this code, it is compiling it on the fly like that, and that's how Python works. So Python is an interpreted language, right? So benefit the drawbacks and benefits on the both sides. So I'm not going into those details. Just wanted to make sure that we understand what's the benefit of Java over other languages. That's compiled, that's interpreted, and this is just in time. That makes Java architectural neutral, and that's a big word. Architectural neutral, meaning that machine, that computer, your Windows, your MacBook, or whatever you have, it is not dependent Windows. If I say in Windows, there could be two different processors. So it is not tied to that, and that's a huge point of Java, that it is architectural neutral, and it could be run on any device. Your Android is all Java. So Java is architectural neutral. Now, since Java runs in a JVM, that makes Java very secure. Java is not going to access computers' processors. So drawback with C++ was that C++ runs on your machine. So if there's a virus that comes in there, in the machine, it can have access to your C drive and wipe out the whole thing. And when Java came in, that's something Java had the biggest advantage over all the other languages. And it said that, hey, it's going to run in JVM, and that meant that if there's a virus, it is limited to the virtual machine. It doesn't have access to your C drive, so it cannot wipe out your hard drive and things. So more secure. So Java is more secure, more portable, architectural neutral. So some of these things made the Java what Java is. They're the most number of developers in Java. The resources in Java are huge. Library of Java. That's called. Then there's the libraries. Then there's the API also there. So resources, number of programmers available. It's there for the longest time. Cannot be compared with any other language. So that's with that, I'm going to wrap up this video, where I've discussed programming languages, what is the purpose of those over the years, how languages have changed, and every time language gets changed, a new version comes in, a new language comes in, it gives us some more addition to the language in terms of how it solves a problem. That communication from English to binary to code, all these languages try to make it easier and easier over the time, so that more people can use programming languages. That's that, and why Java, which is architectural neutral, more secure. It has more resources, libraries. Thank you for watching, folks.